Right, so we're going to introduce the coordinate system. Coordinate system was made by Descartes, the I think, therefore I am guy. And in it, what we're doing is we're mapping all of space around an origin. And what the origin is, let me get an example here, is we define a 0 point. So I'll make a vertical line here. And a horizontal line here. And we'll make these our axes. And axes are special things. I'll write the word over here. So axes measure one variable. So what happens is our axes here are used to measure the distance from this point here, which is going to be our origin. It's our starting point, and it has the special values where x is 0 and y is 0. So notice how I write that as coordinate pairs. And so this is the x-axis. And however far I go in this direction is my distance in x. This is my y-axis. However far I go up or down is my distance in y from the origin. So if this is 1 and 1, 1y, 1x, 2 and 2, all the ordered pairs over here are positive. I'll have some positive value of x and some positive value of y. We call this quadrant 1. We write that with a Roman numeral 1. But all the xy values over here are positive, and we write them x, y as an ordered pair. So if I wanted to plot 2, 1, I'll make that a bright purple here. So the point 2, 1, I come over 2, 1, 2, and up 1. And so this is 2, 1. And it represents a point in space. And so we're dividing our space with an origin that starts at 0, 0, and we measure distance from that origin along the x direction or the y direction. And so depending on what our variables represent, we start getting a visual representation of what our algebraic expressions are doing. So quadrant 1 is positive, positive for both the x and y value. We come over to quadrant 2, which is over here. So we're naming these counterclockwise. This is quadrant 2. Well, the x values over here are -1, -2. So the x is negative and the y is positive. And over here, we could have a point of -2, +1. -2, +1. And that's that point in space. That tells us where this point is. Again, continuing our naming convention, we come down here, and this is quadrant 3. Again, in Roman numerals. Now here, all the x values are negative, and all the y values are negative. So quadrant 3 is negative, negative. And we'll do the same naming down here. We'll do -2, -1. We'll go over -2 and down -1. So this is -2, -1. So notice we actually can make a place on a flat piece of paper that represents each set of numbers. And this is going to help us really start describing what equations do, because they'll let us start looking at them as geometric figures that have behavior. And so over here is quadrant 4. All our x values are positive, and all our y values are negative. And so I can do a point positive 2x, negative 1y. 1, 2 positive, negative 1. And right here, that's going to be positive 2, comma, negative 1. And so we have these 4 points that are all the same distance from the origin, but they lie in different directions. And so the ability of the axis system is to have a place that's 0, 0, and to be able to move in a positive, negative direction from it. We can map out any point on a flat surface. And this lets us start treating our equations that way. So to plot points, what you want to do, to plot a point, is start on the origin, move left or right on the x-axis according to the value of the x-coordinate. And the left is negative and the right is positive. Then move up or down according to the value of the y-coordinate. Up is positive and down is negative. And the place you end up is, draw your point. So let's do some example points here, and we'll make a list of points. So I want 0, comma, negative 3 will be my green point. 5, comma, 0 will be my orange point. Negative 3, comma, negative 4 will be my kind of pinkish point. And 4, comma, 3 will be my bluish point. So let me draw an axis on here in purple. Get my ruler out. There's my ruler. I'm flat. So I'll draw my x-axis first. Put my y-axis in here. Alright. So this is my y. This is my x. Make even tick marks on this. Your graph paper already does this for you, so you'll do better than I do freehand. That's 1, 2, 3, 4, 5, 6 in the positive x direction. 1, 2, 4, 5, 6 in the negative y direction. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. 1, 2, 3, 4, 6 in the negative x direction, so negative 1, negative 2, -3, -4, -5, -6, and let's go up in the y. 1, 2, 3, 4, 5, 6, and the positive y. So using those steps for our first point, we go 0 on the x-axis, so that keeps us on the origin, and then a -3 on the y. 1, 2, 3. So we draw our point here, and this is 0, -3. Our next point, 5, 0. So we go 1, 2, 3, 4, 5 on the x direction, and 0 on the y, and we draw our point. 5, 0. Now we want to go -3, -4. So 1, 2, 3. There's -3. 1, 2, 3, 4. There's -4. So we draw that point there. That's -3, -4. And our last point is 4, 3. So 1. Let me get my color right. 1, 2, 3, 4. And then up 3. 1, 2, 3. And that's 4, 3. And so that's how we plot points on a Cartesian graph system. And what we'll do next is we'll take our linear equations and we'll take our solutions to those and we'll plot them. And we'll actually start seeing why we call them linear.